In this chapter, you will learn the physiological chemistry needed to understand the functioning of the human body. Read through the objectives we will be covering in this video. Atoms are the smallest stable units of matter composed of subatomic particles. These include protons that are positively charged and neutrons that are neutral or have no charge. The protons and neutrons are found in the center of the atom in an area known as the nucleus. Electrons are negatively charged and are found traveling around the nucleus at a high speed within an area called an electron cloud. For the definition of an element, please read through this slide. The periodic table is a tabular display of the chemical elements and includes the atomic number, atomic symbol, and atomic mass for each element. We will focus on the atomic number and symbol for the purpose of this lecture. In the example, we see that helium, denoted by He, has an atomic number of 2. The number of protons is equal to the atomic number, thus 2 protons are present in the nucleus of helium. In a neutral atom, the number of electrons is equal to the number of protons, and 2 electrons are found orbiting in the electron cloud. Isotopes are atoms of the same element whose nuclei contain the same number of protons but different numbers of neutrons. If we look at the example provided, in A, B, and C, there is only 1 proton. In A, there is no neutron, in B, 1 neutron, and in C, 2 neutrons. As we can see, the number of protons are thus the same in all 3, but the number of neutrons differ. These are regarded as the isotopes of hydrogen. We already know that electrons travel around the nucleus at a high speed in an area called the electron cloud. We can determine the amount or number of electrons that an atom has by looking at the atomic number. As previously stated, the atomic number tells us the number of protons an atom has, and this is equal to the number of electrons in a neutral atom. In hydrogen, the atomic number is 1, and therefore it has 1 proton and 1 electron. Lithium has an atomic number of 3. It therefore has 3 protons and 3 electrons. Within an electron cloud, electrons occupy an orderly series of energy levels. The first electron shell is the one closest to the nucleus, while the valence shell is the outermost energy level and forms the surface of the atom. In hydrogen and helium, the first energy level is the valence shell, while in lithium and neon, the second energy level is the valence shell. Each energy level is limited in the number of electrons it can hold. For example, the first energy level is the lowest energy level and can hold a maximum of 2 electrons only. As shown in the image, the second and third energy levels can hold a maximum of 8 electrons each. The number of electrons in the valence shell determines the chemical properties of the element. Atoms with unfilled outer energy levels or valence shells are unstable and will react with other elements or atoms in order to gain stability. They will either gain, lose, or share electrons to gain stability. Atoms with filled outer energy levels are stable or inert and will not react with other atoms. As mentioned in the previous slide, atoms with unfilled valence shells will either share, lose, or gain electrons to become stable, and this creates the formation of chemical bonds. We will look at the following 3 types of chemical bonds: ionic bonds, covalent, both polar and nonpolar, and hydrogen bonds. As the name indicates, ionic bonds are formed between ions. Ions are atoms or molecules that carry an electric charge. An atom that has lost an electron becomes positively charged and is known as a cation, whereas an atom that has gained an electron becomes negatively charged and is known as an anion. Ionic bonds are chemical bonds that are created by the electrical attraction between cations and anions. One atom will lose one or more of its electrons and is known as the electron donor, while another atom, known as the electron acceptor, will gain those same electrons. When ionic compounds are placed in water, such as table salt, they will dissolve. To better understand the formation of an ionic bond, let's look at the example of sodium chloride. From the periodic table, we see that sodium has an atomic number of 11 and chlorine has an atomic number of 17. Using this information, draw the electron clouds with the number of electrons that are associated with each atom. Now determine which of the two atoms will gain an electron or lose an electron in order to gain stability. The sodium atom has an atomic number of 11, therefore there are 11 electrons. In the first energy level, a maximum of 2 electrons are found. In the second energy level, a maximum of 8 electrons are found, and in the third, only 1 electron is found, giving us a total of 11. The chlorine atom has an atomic number of 17, hence 17 electrons. The first energy level will have 2 electrons, the second will have 8, and the third will have 7. Because the third energy level can hold a maximum of 8 electrons, both atoms are unstable. Sodium loses its electron to gain stability, becoming an electron donor. Because it's donating a negative particle, it ultimately becomes positively charged and is known as a cation or the sodium ion. The chlorine atom gains that extra electron to complete its valence shell. As it's accepted a negative particle, it gets a negative charge and is now known as the chloride ion. The attraction between the positive and negative charges creates an ionic bond. When atoms share electrons with other atoms, instead of gaining or losing, covalent bonds form. Single covalent bonds share one pair of electrons, as can be seen in the example of the hydrogen molecule, whereas double covalent bonds share two pairs of electrons, as can be seen in the example of the oxygen molecule. Covalent bonds can either be nonpolar or polar. Nonpolar covalent bonds involve equal sharing of electrons. In the example provided, each hydrogen atom has one electron in its valence shell. As the first electron shell can hold a maximum of 2 electrons, the two hydrogen atoms share their electrons with each other. This results in the formation of the hydrogen molecule. Because each hydrogen atom has one proton in its nucleus, the electrons spend an equal amount of time near each nucleus due to the same charge on both nuclei. On the other hand, polar covalent bonds involve unequal sharing of electrons, often creating polar molecules, molecules with slightly positive and negative ends. Let's look at the example of the formation of a water molecule, H2O. Water consists of 2 hydrogen atoms and 1 oxygen atom. The atomic number of hydrogen is 1, it therefore has space for 1 more electron in its valence shell. The atomic number of oxygen is 8. 2 electrons will be found in the first energy level and 6 in the outermost energy level. It thus has space for 2 more electrons. Electrons are shared between the oxygen and hydrogen atoms, but what exactly makes this an unequal sharing? If we look at the nucleus of the oxygen atom, it has 8 protons. The nucleus of each of the hydrogen atoms has 1 proton. Because the oxygen atom has a more positive charge in the nucleus, the electrons spend more time near the larger or more positive nucleus. Therefore, oxygen is slightly negative due to the electron spending more time around the nucleus of the oxygen atom as compared to the hydrogen, which is now slightly positive. Hydrogen bonds are weak attractive bonds. Let's look at the formation of hydrogen bonds between water molecules. In the previous slide, we learned that a water molecule is a polar covalent bond because it has a slightly negative charge on the oxygen side and a slightly positive charge on the hydrogen side. The hydrogen bond is then an attraction between a positively charged hydrogen in a polar covalent bond, and in this case, a negatively charged oxygen in another polar covalent bond. The attraction can also occur between a positively charged hydrogen in a polar covalent bond and a negatively charged nitrogen or fluorine of another polar covalent bond. To complete this section of the lecture, please go through these terms on your own.